Hi, good evening. My name is Santiago Campero, and this is my presentation for the data sampling lab. So in this slide, basically, I show you the introduction and where my idea came from. So last week, I was watching a video, Blue Pen, Red Pen. It's a math channel on YouTube, and I saw how he was able to combine a bunch of sounds and transform it into just one sound, and also how coming from one sound using Fourier transform theory, he was able to pull out some of the frequencies of that sample. And my first thought was, is it possible to do the same thing? And how to do it? How hard it is? And well, during this lab, I found out it's extremely hard to pull apart a already consistent sound. It's extremely hard, like graduate level hard. So that's why I decided to change a bit the shape of this experiment into more of an assembly. At first, I wanted to do like a disassemble of the original sound, and now I want to do an assembly of all this actual sound that comes. And how could I apply that? I thought of this song that means a lot to me. I really like this song by Maroon 5. It's called This Love. And online, I was able to find bits and pieces of part of the song that I enjoy the most. And in the different instruments, so like vocals, drums, guitar one, guitar two, bass, um, the the piano, keyboard, and all of that. And I was able to record the exact same part of the song using those. Um, yeah, and that basically is what inspired me, and that is why I'm doing this introduction. Basically, the goal would be to assembly this song, or at least similar to this song, using the individual parts. Now, the approach I had for this was first getting the software, getting accustomed to the software and the hardware that was given by the TA. And I did basically a bunch of trials. I did the validation, and all of this was set up in a quiet room with minimal noise, so that there would not be any interference in my recordings. And I was able to record those bits and pieces, having the microphone stationary in the same place. And yeah, so I was able to record all of those sounds. Now, for my results, first I decided to use these. Well, these equations had to be used first for the XRMS. It was used for normalizing the sound such that these differences that I spoke about, since I got these bits and pieces from different places, would not affect as much the sum of the graph. And then also the hypothesis, which is that summing the frequencies and the voltages of these bits and pieces, I would be able to get the song. So first, this idea was so hard to pull off in MATLAB. It was extremely hard. I spent like at least 5 hours on it. But yeah, so since the recordings had different lengths, I had to pad them with zeros. I created a bunch of vectors that were only zeros, that had the length of the of each instrument that did not have enough length to the length of the instrument that had the most length. So that way, like just the ending, just the tail of the signal graph would not affect me as much. And yeah, so first, this is how the graphs of each of the instruments came out. As you can see, they all uh, kind of start at different places, and I was very worried about that, uh, since it would, I don't know, I was very worried that maybe I started too late, or maybe I started too early at some points. But it turns out it's just the way the song works. There are, at that point of the song, it starts late, it starts before, it starts at different paces. And yeah, so I was able to come back from that. Also, for the MATLAB graph, at the end, after many tries, I was able to get this graph. And here we can see the results of the experiment. We have many points where this is where the graph looks similar, although it looks like a bit shifted upside. But still, nevertheless, there are many points where this is similar. It starts and ends at the same time too, which is a great sign. In conclusion, yeah, this is a successful experiment, although it could be using better equipment, better samples, and yeah, the graphs look similar. So yeah, thank you so much.